All right. So 3.1, we're starting a brand new chapter all about systems of equations. So we're doing 3.1 day 1. And first off, let's talk about what is a system, right? What is a system of equation? So let me define it for you. So a system of equations, right here. How many equations does a system have? It just can be 2 or more. So typically you guys are going to get systems that have 2 equations, but it is possible to have 3 or 4, all right, et cetera, et cetera. And what is special about the variable? It's just that there's typically 2 or more variables, right? So 2 or more variables in a system. All right. And it's not a coincidence that those numbers match. If you have 2 equations, you need if you have 2 variables, you need 2 equations to solve for both. If you have 3 variables, you need 3 equations to solve for all 3 variables. Okay, so that is not a coincidence. All right, so how many solutions do each type of systems of equations have? There are some various answers to that question. All right, and because there are various answers to that question, there's different types of solutions, okay, in a system. Now, it's called consistent if there's at least one solution. Okay? It's called consistent if there's at least one solution. It's called independent if there's exactly one solution, exactly one. It's inconsistent if there are 0 solutions, and it's dependent if there's infinitely many solutions. All right, so let me show you like some quick sketches of these situations. So for example, if I have graphs of the 2 equations that intersect at one point like this, this is considered consistent and independent, because there's one solution to that system. It intersects at one point. So it's consistent and it's independent. If I have a situation where the 2 lines overlap each other and have infinitely many solutions, this would be considered consistent and dependent. Okay. And the last type is if you have like parallel lines and they do not intersect. If they do not intersect, then this is just considered inconsistent. All right, I'm gonna be honest with you guys. The solution types, I would not spend that much time studying. I actually don't feel like you see the question about classifying the type as opposed to just finding the solution. So I think it's more important that you guys are able to find the solutions to a system as opposed to classifying the type, okay? So I'll be honest, don't worry about studying and memorizing these terms. I'm not gonna put it on the quiz, okay? All right, here we go. Let's try some examples. So graph each of the following systems of equations to find the solution set. We'll classify the type just because, you know, we can. But again, don't worry about memorizing these terms, okay? All right, so help me with some graphs here. Let's start with Riley. All right, number 1. Help me graph.
So you look at the y-intercept. Are we doing number 1?
Yes.
Okay, so y equals 1 half x minus 1. So just that graph, so -1 as the y-intercept.
Mm-hmm.
And then play it out probably. So up 1 over 2.
Mm-hmm. Oh, sorry, that line got lost. 1, 2. Okay.
And then y equals -2x plus 4. So y-intercept's 4.
Okay, keep going.
And then -2, so down 2 over to the left 1.
Oh, wait, to the left?
Or to the right, sorry, it's negative.
Yeah, so you go down, and that already takes care of the negative, and then you go to the right. Okay? And then I
They
grab
should,
line.
yeah, and then they intersect at that one point, which is 2, 0.
Mm-hmm.
And then this is where I kind of get confused. I don't know where to go.
Okay, good. No, that was perfect. So you have the point 2, 0 as your solution, and that is how you guys want to write your solution in these coordinate points. All right. So now we have one solution to our system. So it's similar to this guy up here, right? So we have one solution. So we have independent and consistent. Okay. So that would be the type, would be independent and consistent. Since there's exactly one solution. Does that make sense, Riley?
Yeah.
Yeah, okay, good job. All right, let's go number 2. Joanne, help me out with this one.
So you divide 3.
Good. So I get
and
1/3 of x.
So you start from 0, right?
Good, yeah.
And then you rise over 1 and run 3.
Good. So I go up 1 and then to the
Right.
good.
2.
Nice. Perfect. So I draw that line. And then Joanne, what do you notice about the second equation?
They intersect.
Yeah, it's like the exact same line, right?
Mm-hmm.
So how many answers do I have? How many points of intersection do I have?
Infinite.
Good. Yeah, it's the entire line, which is infinitely many points. So then my solution is basically that I have infinitely many solutions. So infinitely many solutions. All right. And then what about the type? What do you think?
Is consistent and dependent.
Good job. All right, consistent because there's at least one, and it's dependent because there's infinitely many. Good. So consistent and dependent. Good job. All right, keep going, guys. Number 3. All right, number 3, help me out with this one, please. Paolo.
I don't know where I would start. Would it be 2, -2? Or would it be
Which one are you on, the first equation or the second equation?
the first equation?
Okay, so what's the y-intercept on that one?
3 over 2.
That's the slope,
Oh, my bad. It's 2.
2. So I'm going to start at +2 for my y-intercept. Okay, and then you said the slope was 3 over 2. So how do I graph this? Where do I go?
So we rise 3 and then over 2.
Perfect. Good. And the more consistent you are with that graph, the easier it will be. So here it is. All right, and then what about the second one, Paolo? What do I do with that one?
That's where I get confused. I don't know for sure.
Okay, no worries. So the reason why you could graph the first one was because it's in slope-intercept form. And you know it's in slope-intercept form because it's y is equal to mx plus b. So the second one, in order to graph it, you got to put it into that form. So solve for y. So let's go ahead and solve for y here. How do I solve for y? What should I do first?
Would it be isolate the variables?
Okay.
So it would be plus 3 already.
Plus 3x.
3x.
Okay. Good first one. All right. What else do I have to do to isolate y?
And then divide 2y by 3x plus 8.
I don't want to divide 2y by 3x plus 8. I need to get y by itself. So what do I need to, what's not allowing y to be by itself? What's with y right now?
2.
2. So how do I get rid of that?
Isn't it just divided by itself, or?
Not divide by itself, but divide by, what do I divide both sides by?
I don't know.
To get y by itself, divide by 2.
Oh.
Yeah. If you divide by 2, look what happens. Y is by himself. You see how that works?
Yeah.
Yeah. All right. So when you divide 2 on the other side, be careful. Make sure you divide both terms. So we have 3 over 2x plus 4. Now can you graph this?
Yeah.
Okay. So then where do I start?
It'd be you start on 4
Good.
because it's your y-intercept.
Yeah.
And then it would be rise 3 over and then run 2.
Mrs. Leong, we can't see our share screen. It froze.
Gross. Okay. Thank you. Wait. Are you sure?
Yeah, mine froze.
Yeah, mine froze too. Like there's nothing happening right now.
What do you see right now? Do you see the y?
I just see one line and that's it.
Yeah, there's only one line so far.
Oh, okay.
Yeah, you're good. Yeah. So for the slope, here, rising 3, running 2, you kind of go off graph. So if I want to keep on the graph, I would go down 3 and then left 2, right? Because I have no room to go up. So I'm going to go down 3, left 2, and then you get this graph. Ethan, can you see that second line?
Yeah, okay. Yeah,
Okay.
I can see it now.
Good. All right, so notice we have parallel lines. So Paolo, how many points of intersection do we have with these two lines?
It would be inconsistent.
Good. And how many solutions do we have?
Just 2, right?
Well, no, how many times do those parallel lines intersect?
Oh, never.
Never. So there's no solution. I'm going to put it down here. Or no, I'll put it up here. So no solution. And you're right, this is inconsistent. Good. So when you're solving for a system, basically you graph the lines and any points of intersection would be solutions. So like number 1, we only had 1 point of intersection. So 2, 0, that was the solution, the one solution. For number 2, they intersect at all the points. So all of those points are solutions. And there's just too many right. There's too many to write. So we just write infinitely many. But number 3, they're parallel. They never intersect. So that means we have no solution. All right, any questions on solving using graphs? Okay, let's go to solving using substitution. All right, and these are the methods that I think people typically use more. All right, so let me show this first one. So number 4, I'm gonna solve using substitution. Now the reason why I know to use that is because y is already solved for here. So it's really easy to substitute because y is equal to negative 2x plus 7. I can go ahead and plug that into this y in the first equation. All right, so I'm gonna have 5x minus 3, use parentheses, and plug in negative 2x plus 7 is equal to 23. Okay, take it from here, please. Russell.
So first you want to like distribute the numbers.
Yeah, keep going. Tell me what to write. 5x.
So you would get 5x plus 6x and then minus 21 equals 23.
Good, keep going.
And then you could add 21 to 23.
Good.
And then you would get, and then add 5x and 6x. And then you get 11x equals 44.
Good.
Then x equals 4.
Nicely done. All right. Now, Russell, are we done? Solve for x?
No, we need to plug it in for y.
Good. All right. So where should I plug that in?
So you would get y equals minus 2x times 4 plus 7.
Good. Negative 2 times 4 plus 7. And what do we get?
We get 15.
Ooh,
Or
right.
no, never mind. That's a negative. Minus 1.
Yeah, there it is. Minus 1. Good. All right. So when you guys write your answer, write it like the coordinate pairs. So we have x is 4, y is negative 1. Ooh, now I remember why this is my favorite. This is one of my favorite chapters because you can check your answers and make sure you get 100% on this question by just plugging in x and y and double checking, making sure that it solves for the system. So what I mean by that is plug in 4 for x and negative 1 for y into this first equation and just double check that it works. And do the same thing for the second equation, negative 1 for y, 4 for x, and we get negative 1 is equal to negative 1. So if you plug it back into both equations, you can double check and make sure that you get 100% on this question. Okay? All right, any questions on that one? All right, let's try number 5. So number 5, it says use the substitution method still. So I need to use substitution. And it was really nice when I solved for one of my variables here, right? It was easy to substitute. The setup isn't quite as nice here. So what should I do? Chris, what should I do to kind of set it up better?
You should put that second equation, or actually, you have to put both equations in y equals mx plus b form.
Actually, you only need one equation. You need to solve for a variable. So which variable is the easiest to solve for?
X.
X, yeah. So solve for x by adding the 7y. And now this you can plug in to that x. All right, so Chris, take it from here. Substitute it. I get 5 times.
5 times, well, you have to solve for the equation above, right?
Oh, yeah, I already did that.
Oh, what was it then? Okay. So it's 5 times 7 y plus 11 and parentheses plus 4 y equals negative 23.
Good, keep going.
So then you would do 5 times 7y, 35y
Mm-hmm.
plus 55
Mm-hmm.
plus 4y equals negative 23.
Good.
Subtract 55 from 23.
Good. I get negative 78. Uh-huh. Keep going.
And then you can add like terms.
Mm-hmm. Good.
So it'll be 39y equals
Good.
negative 78.
So
And
y equal to,
divide 39 by 78, right?
uh-huh, yeah, it goes in nicely.
I don't know.
It's okay. Negative 2.
Y equals negative 2.
There
Then,
you go. All right, and then Chris, we're done, right?
yeah, and then you can plug it into checkers.
Ooh, no, that was a trick question. We're not done. What do we still need to solve for?
Oh, you gotta solve for x2, right?
Good, yeah.
Or,
Help me solve for x. What would x be equal to? Where do I plug in negative 2?
oh, it could be 7 times negative 2 plus 11.
There you go. We get negative 3. All right. And like you said, you want to write your answer. So negative 3 comma negative 2. Make sure the x comes first. And then you can plug it in to double check. All right. Good job, Chris. Okay. Let's go to our last part here, elimination. All right. Now this actually I think is probably one of the more helpful ways to solve for these systems. Okay. Because it's not always easy to isolate a variable first, because that's your first step for substitution, is to get one of your variables solved for. In this case, it's not so great because you end up with fractions. So instead, we're going to use the elimination method. Let me show you how to do this one. So the idea behind elimination is you're going to combine your equations before you solve for any variables. Okay, and you eliminate, you combine it in a way that eliminates a variable. So if I'm looking at x and y, I have to decide which one I want to eliminate first. And in this case, if I add my two equations together, and I add the x's together, I get 6x, right? When I add 4x plus 2x. And when I get negative 3y and I add 3y, I get 0y. So that eliminates the y variable, which is why it's called elimination method. And I got negative 22 plus 16, and I think that's negative 6. And that gets you x's negative 1. Right, so elimination method is really nice. Now remember, you do have to plug back in though to solve. So you can pick either of these two. I think the bottom one is a little bit easier because there's smaller numbers. So I'm going to plug in negative 1 for x. And then I solve for y.
Mrs. Leong,
Yeah, question.
may I use the restroom real quick?
Yeah, go for it.
Thank you.
All right, and that is my answer. And again, remember, plug in those numbers back into the equations just to double check, okay? And you can guarantee 100% if you do that. All right, let's try number 7. Help me out with this one, please. Mateo. All right, Mateo. First question. What looks easier to eliminate, x or y?
X.
Good, yeah, because what do we need to multiply in order to get those coefficients, the numbers in front of x, to be the same?
2.
Yeah, and actually I'm going to multiply this. I'm going to make it a little easier. I'm going to multiply this by negative 2. So I'm going to get negative 12x plus 8y is equal to negative 60. And the reason why I say that's easier is because now you can just add those together. All right, so Mateo, what do we get when we add those together? What happens to those x's?
They cancel out.
Good. What do I get for the y's?
13y.
Good. And what do I get on the right-hand side?
Negative 78.
Good. All right, and does that turn out nicely? Oh yeah, y is equal to negative 6. Okay, Mateo, what do I do from here?
You plug negative 6 into one of the equations.
Good. Which one do you want to use?
Do you put it into like the original one or the one you multiplied by negative 2?
I would do the original one just because the numbers are smaller.
Okay, then the first one.
All right, go for it. Tell me what to write.
6x minus 4 times negative 6 equals 30.
Good. Okay. Keep going.
6x plus 24 equals 30.
Mm-hmm. So 6x is equal to?
6.
Good. So x is equal to?
1.
1. All right, good job, Mateo. Let's go, Angie. Angie, from here, how should I write my final answer?
Parentheses 1, comma, negative 6.
Good job, Angie. All right, and then Sebastian, what can I do to guarantee I get 100% once I have my answer? Sebastian?
Oh, I'm unmuted. I'm not entirely sure. I don't think I quite get it yet.
Were you paying attention?
Yeah, yes, but yeah, I don't think I can completely get it. I'm gonna take a look at the video later. Just
Okay, well, you can ask me questions too.
yeah.
So to guarantee that you get 100%, you plug in your answer, x and y, into your equations. So Sebastian, help me plug this in.
Okay, so 6 plus 24 because minus 4 times minus 6 is 20 plus 24 positive.
So does that work?
Yes, it does.
Okay, and then do that for the second one.
Okay, so 12 positive minus 30 is equal. Yeah, that's also true.
Okay, so that guarantees that you got 100%, and that is the correct answer. Does that make sense?
Okay.
Okay. All right, let's go to our last problem. Okay, so number 8. Let's go to Zoe. Can you read this one out for us?
Yeah. On a farm, there are a total of 48 cows and chickens. How many each type of animal are there if there are a total of 126 legs? Write and solve an equation.
Okay, so your everyday farm problem, right? So let's call cows X, and let's call chickens Y. Okay, so we have 2 variables, so we need 2 equations. Okay, so help me set up one of those equations. Michael, Y.
You could do like 126 legs.
Yeah.
Okay, so you could do, I guess, 48x plus y or something like that.
Oh, okay. So there's total of 48 animals. So if I have 48 animals.
Oh, 48 animals. Gotcha. All right.
Yeah, so I don't have 48 cows. Sorry. There's a total of 48 cows and chickens. So how can I write that as an equation?
Hold on, I gotta think about this one.
That's good. Yeah, so X is the number of cows, Y is the number of chickens. So we have a total of 48 animals.
I guess you could do like 48 times X times Y equals 126.
Ooh, not quite. So X is the number of, okay, if I have 2 cows and 3 chickens, how many total animals do I have?
You have 5.
I have 5,
animals.
right? So if I have X number of cows and I have Y number of chickens, how many total animals do I have? What do I do with those 2 numbers?
It equals 48.
Yeah, so what's the equation?
So X plus Y equals 48.
There you go.
Okay.
Yeah, okay, so we have total of 48 animals, X number of cows, Y number of chickens, they total to 48 animals. Okay, number of legs. Joseph, how are we gonna do that? How would we write that equation?
For the number of legs,
Yeah, how many legs does a cow have?
a cow has 4.
Okay, good. So I have X number of cows.
Yeah.
How many legs?
What? Okay, so the X number of cows, and there's 4 legs. I'm not really sure.
Okay, if I have 2 cows, how many legs?
8 legs.
If I have 5 cows, how many legs are there?
20.
If I have X number of cows, how many legs are there?
X. What is the X? I'm not sure.
X is the number of cows.
Okay.
So what did you do with, if I said 5 cows, you said there's 20 legs. So what did you do with that 5?
Oh, I multiplied by 4.
Okay, so if I have X number of cows, how many legs?
Multiply by 4.
Good, so 4X represents how many cow legs there are. How many legs does a chicken have?
2.
2. So how many chicken legs do I have if I have?
Oh, would it be plus 2y?
There it is. Is equal to?
126.
Yeah. You got it.
Yeah.
Good job. Okay, let's solve. So you guys, I'll go ahead and let you solve however you want. You can use substitution, you can use elimination. I don't recommend graphing, okay? Solve, and then I'll call on somebody and see how many chickens and cows we end up with. Betty. All right, Betty, what do you have so far?
Wait, do I say how to like do it or like?
We don't actually have the time. We're out of time, so just tell me your answer.
Oh, I got 15 and 33.
Good, yeah. So 15 of what animal?
15 cows and 33 chicken.
There you go. Good job. Okay. Great job, guys. So practice that with homework and let me know if you have any questions. All right. Have a good day. Bye.